Welcome back with a new math tutorial. This video you will know how can we graph the proportional relationship. Before we start with graphing, we need to identify what is the meaning of the coordinate plane. The coordinate plane formed from the intersection of two numbered lines. We have here the horizontal line which is defined by the x-axis and the vertical line defined by the y-axis. Both of them intersect at their zeros and the point of intersection defined by 0 and 0. 0 for x and 0 for y. 0 and 0 is called the ordered pair. The first point here is called the x-coordinate, and the second point here defined by the y-coordinate. So for any ordered pair will be equals to x and y. So now we have the coordinate plane which formed from the intersection from the x-axis and the y-axis. Both of them intersect at their zeros. The point of intersection defined by the origin point, and it's equal to 0 and 0. 0 and 0 defined by the ordered pair. The ordered pair, the first point here is called the x-coordinate, and the second point defined by the y-coordinate. To represent any ordered pair on the coordinate plane, at the first just move how many units in the x-axis. If x is positive, it means we are moving to the right. If x is negative, it means we are moving to the left. But if x is equal to 0, it means we will not move right or left. Now for y. We are moving up and down. If y is positive, it means we are going up. If y is negative, we are going down. So suppose that we have here the point 2 and 3. 2 and 3, it means moving 2 units to the right and 3 units up. So that would be the place of the point 2 and 3. But if we have negative 5 and 1, negative 5 it means we are moving 5 units to the left. 1 it means we are going 1 unit up. So that would be the place of the point negative 5 and 1. In this problem we are talking about the slowest mammal on the earth. Its speed is equal to 6 feet per minute. We need to graph this relation and we need to find if this relation will be a proportional or not. At the first we need to identify the units of the rate. We just have the relation between the number of feet to the number of minutes. The second one represents the x-axis, so this one will be equal to the minute. And the first one represents y, so that will be the feet. For each 1 minute, it will move 6 feet. Now for 2. 2 times 6 equals to 12. After 3 minutes, it will move 18 feet. After 4 minutes, 4 times 6 equals to 24. Now we need to graph. As we said before, we have two numbered lines. The x for the horizontal line and y for the vertical line. Now we need to represent the relation graphically. The first point here is 1 and 6. It means moving to the right 1 and going up 6. The second 2 and 12. After that 3 and 18. The next one will be 4 and 24. Now we can graph. From the graph you will find that we have a straight line passing through the origin point. Once we have here the first one which is straight line. The second point that we have a straight line passing through the origin point. If we have a straight line passing through the origin point, it means this relation is proportional relation. You can make sure that if this relation is proportional or not by finding the rate. Finding the rate of each one. 6 divided by 1 equal to 6. And 12 divided by 2 equal to 6. 18 divided by 3 equal to 6. 24 divided by 4 equal to 6. It means the constant rate of change now would be equal to 6 feet per minute. In this table we have a relation between the number of games to the cost. We need to represent this relation graphically, then identify if this relation is proportional or not. The first point that we have, which is 1 and 3. Just moving 1 to the right and 3 up. After that, 2 units to the right, then 5 up. The next one, 3 and 7. And the last one will be 4 and 9. Now by graphing you will find that we have a straight line. This straight line is not passing through the origin point. Once we have a straight line, not passing through the origin point, so this relation is not proportional. The relation is proportional only if we have a straight line passing through the origin point. If we have one of the two conditions is not applied, it means this relation is not proportional relation. In this table we have a relation between the number of minutes to the number of calories. We need to graph the relation, then identify if this relation is proportional or non-proportional relationship. At the first we have 0 and 0. Then 1 and 4, moving 1 to the right and going up 4. After that 2 and 8, moving 2 to the right then going up 8. The third unit is 3 and 13, just moving 3 units to the right and 13 up. By graphing, you will find that this graph is not representing a straight line. It will be as a broken line. Once we have here the relation is not a straight line, even if that's passing through the origin point, but this relation not represented as a straight line, it means this relation is not proportional. The relation is proportional only if we have a graph represented by a straight line, and this straight line must be passing through the origin point.